Okay, good evening Shafia, good evening, good evening. Okay, what about others? Good evening, good evening. Okay, so in the last class we were discussing about the proteins. So we'll finish this particular proteins and we will move on to the enzymes and its kinetics. Is it? Okay. So if every one of you very quickly recall, friends, in the last class we were studying about, good evening everyone. In the last class we were studying about the secondary structures of protein. When we are studying the secondary structures of protein, friends, we are understanding about the alpha helix and we are understanding about the beta sheets, as well as, friends, we are understanding about the beta bend or beta loop. Okay, so listen to me very carefully. If every one of you very quickly recall, I have told you that, friends, in case of a alpha helix, there is only right-handed helix is possible. And what we have discussed, friends, we have discussed that the left-hand helix is not at all possible. What is the reason why the left-hand helix is not possible? Friends, the left-hand helix is not possible because of the steric hindrance. But if every one of you quickly recall my words, we have very clearly discussed that, friends, in case of a beta pleated sheets, what we understand? We understand that we can see a parallel beta pleated sheets, as well as, friends, we can also see anti-parallel beta pleated sheets. If everyone quickly recall, what do you mean by the word parallel beta pleated sheets? You can see here in both direction there will be a same domain. See, this direction also amino terminal domain, and, friends, this direction also amino terminal domain. Correct na? Whereas, good evening, if you look into the anti-parallel, what you can observe, in one direction there is a amino terminal domain, in another direction there will be a carboxy terminal domain. That is what we can call it as the anti-parallel beta pleated sheets. Good evening everyone. Okay, please continue, friends. And what kind of question that we can expect in the exam? All the students, please listen my statements very carefully, friends, without having any kind of a confusion. If every one of you very quickly recall, they can ask a question that, everyone remember, they can ask a question that secondary structure of a protein. Everyone please remember, secondary structure of a protein contains both the alpha helix also as well as the beta pleated structure also. Friends, that statement is a right statement or wrong statement? Undoubtedly. I can tell you one particular point. Friends, please listen. 90% of every protein, friends, please follow me correctly, 90% of every protein in their secondary structure, they contain alpha helix also as well as the beta pleated structures also. And only some type of protein, let's consider 10% of the proteins, they contain either only alpha helix, they contain only beta pleated sheets. Most of the time they won't contain both type of the structures. Whereas if you look into the majority of the proteins, friends, good afternoon everyone, if you look into the majority of the protein, there is a presence of the alpha helical also, there is a presence of the beta pleated structures also. Don't get confused with that particular point. And I hope every one of you remembered in the last class what I told to all of you, friends. I hope everyone remembered. We discussed very clearly that, friends, one turn, what, friends, one turn of an helix contains how many number of amino acids? Good afternoon, Abdul. We discussed that 3.6 amino acids will be present. I told you now, friends, if you keep the amino acids in the linear form and if you arrange the amino acid in a ringed structure, the length will be different. Correct na? So that's why, friends, we don't use the word length. What we will use the word? We will always use the word pitch. Good afternoon, friends. What will be the pitch? I have very clearly told to all of you that, friends, the pitch will be 5.4 angstrom. Please do not get confused with this. and we have also discussed, friends, how does this particular hydrogen bonding is getting formed, correct na? So that is also very important, friends. I want you people to remember how does this hydrogen bonding is formed actually. And I told to all of you, first hydrogen, see, always remember, friends, first hydrogen bond will always formed between I2 I plus 4 amino acid, ith amino acid to the I plus 4 amino acid, then followed by, friends, I plus 1 to the I plus 5, then I plus 2 to the I plus 7. So friends, it is very easy to remember, correct na? Suppose example, always remember, all you people always remember where the first hydrogen bonding is formed. Even though they asked for the polypeptide content 20 amino acid, 200 amino acid, 2000 amino acid, it is very easy to calculate. Always consider where the first hydrogen bonding is formed. If you understand where the first hydrogen bonding is formed, you can answer the question. And another very important point every student has to remember, that this amino terminal domain will show the positive partial positive charge, and this particular carboxy terminal domain will show the partial negative charge. So friends, since they are all showing the partial, what do we call them as? We will say that the amino acids can show the dipole movement in a protein. Always remember that particular point without fail. Okay, so friends, I told you now, in the 2022 February paper we got the question from the hydrogen bonding. If they miss, what kind of questions we can expect in the exam in the part B? All the students keep it in your mind. We can expect the questions, friends, based on their stabilizing interactions. This is a very important. What kind of interactions in the helix, or what kind of interactions making the helix to become stable? These kind of questions we can get. Suppose example, every student remember my words very carefully. Friends, don't get confused. Suppose this is the amino terminal domain. Okay, and friends, remember friends, this is the carboxy terminal domain. Suppose example, every student please listen my statements very carefully. Suppose example, if we keep all the positive charged amino acid towards the amino terminal domain, do you think the helix will become stable? No friends, that is not at all possible. But if you similarly, all the students please listen my statements very carefully. At the same time, if in the carboxyl end, if you keep all the negatively charged amino acids, friends, the helix never ever become stable. All the time you people remember that particular point without having any kind of a confusion. What I mean to say that if you keep same charged amino acids, they never makes the helix to become stable. Suppose example, all the students listen to me once again very carefully. You have to remember these statements without fail. An example, this is the amino terminal domain. If we keep here negatively charged amino acids, obviously friends, the helix will become stable. Since this is the carboxy terminal domain, if you keep positively charged amino acids here, obviously friends, helix will become stable. Suppose example, please listen my statements very carefully, don't get confused. Suppose an example, the entire helix, listen to me friends, suppose an example, the entire helix, if it contain hydrophilic amino acids, do you think the helix will become stable? It never. Suppose an example, the entire helix consists of hydrophobic amino acids. Do you think the helix will become stable, friends? No, there is no way that the helix will become stable. Suppose example, the helix contain hydrophobic also, hydrophilic amino acids also, hydrophobic and hydrophilic. Then what is the word I can use? I can use that helix will become highly stabilized. Okay, now please listen my statements very carefully. Friends, These are all the most important characteristics every student has to remember. Okay. 5 different kinds of constraints affect the stability of an helix. Friends, even in the part B question or even in the part C question, also in the form of a statement, so we can expect this particular question. So that's why I'm requesting all of you remember these particular points without fail. Suppose the electrostatic repulsion or attraction between the successive amino acid residues with the charged R groups. I told you now, if only positive charged amino acids are associating with another positive charged amino acid, helix never becomes stable. If the positive charged amino acid is associating with the negatively charged amino acid, friends, then only the helix will become absolutely same. Suppose example, all the students listen my statement. Suppose this is the helix. In the helix, abundant amount of hydrophobic amino acids arranged in a bulk. Listen my statements, friends. Good afternoon. Abundant amount of hydrophobic amino acids arranged in the bulk. Then what we can say that the bulkiness or many groups of same amino acid. Friends, follow my statements very correctly. Many groups of similar amino acids, they will always make the helix to become destabilized. They never make the helix to become stable. And we all people will use 2 words, that is glycine is a flexible amino acid, and we will use the word proline is the rigid amino acid. There is no doubt about it. When there is an abundant amount of glycine is present, friends, I can conclude the statement that it is a flexible. So friends, the helix will become stable. There is no doubt about it. When it is the helix contain proline, it is a rigid, it will break the helix. In other words, we can call it as it will destabilize the helix. What, friends? It will destabilize the helix. There is no doubt about it. Now what you people has to remember for the exam point of view is that, friends, all the students look into this. This is the helix. Now what is the statement I would like to highlight? Suppose example, proline is present here, proline is present here, proline is present here. There is no doubt, friends, helix will break. But what is the greatest advantage with the proline? Suppose example, friends, follow me very correctly. Suppose example, if the proline is present in the starting of the helix. Suppose example, if the proline is present in the starting of the helix, there is no doubt the helix will become highly stable. Because, friends, all the students listen my statements. Listen to me. If the helix wants to become stronger, if the helix wants to become rigid, very strong, it will be requiring the help of a rigid amino acid. So what will be the rigid amino acid? Proline. So please remember, don't confuse. Proline is suitable. Friends, follow me, friends. Proline is suitable and make the helix stable in the starting of the helix. But if we keep the proline in the middle, obviously, my friends, it is going to break this particular helix. Don't get confused with that particular statements. Now all the students look into the diagrams, look into the points. It was written that long block of glutamine residues cannot form alpha helix. Why, friends? All the students listen to me carefully. This is a long chain of helix. Now the entire helix contains glutamine amino acid only. We all people know that the glutamine is the negatively charged amino acid. If only glutamine is present, friends, how does the helix become stable? That is not at all possible. It's not possible. Suppose, in other words, this is the helix. The helix contain repeated amino acids of lysine arginine, repeated amino acids of lysine arginine, lysine arginine. Do you think a helix will become stable? There is no way helix never becomes stable. Why? Because entire helix positive charged amino acids only present, or in other words, entire helix only negative charged amino acids are present. If it's not like that, but if you consider glutamine, arginine, lysine, glutamine, arginine, lysine, if the arrangement is like this, obviously friends, there is a no doubt about it, the helix will become highly stable. Helix cannot become stable in this case also, and friends, helix cannot become stable even in this particular case also. So what is the statement every student has to remember? If the helix wants to become stable, there should not be same charged group amino acid throughout the helix. If the helix wants to become stable friends, we will be requiring both the negatively charged also, we will be requiring both the positively charged amino acids also. Do not get confused with that particular point. Okay, all the students please look into this and remember without fail. Friends, from here also we can get the numerical type of a question. Anyway, if you look into this particular diagram, this is what structure? Alpha helix structure. You all people can see it very clearly. What you can observe very clearly, the R group is not at all, once again every student remember, the R group is not at all involved in the helix. Most of the R groups are located outside and they do not have any role in making the helix to become stable, because they do not involved either in the stabilizing of the helix or in the destabilization of the helix. All the students please look into this picture friends. So one turn, this is called one turn. Okay, all of you look into this. From here to here, this is called one turn. One turn contain, every student please remember, one turn equal to 3.6 amino acid. And friends, one amino acid rotate the helix 100 degrees. Don't get confused friends. One amino acid rotate the helix 100 degrees. Now one turn, one turn rotate the helix how many degrees? Undoubtedly friends, one turn will rotate the helix 360 degrees. Don't get confused. One amino acid rotate the helix 100 degrees. Since one turn contains 3.6 amino acid, then it is around 360 degrees. One turn can rotate the helix. And I also told to all of you, right? Friends, look into this. These are all the distance. You can see, right? One turn, the pitch is how much? 5.4 angstrom. Instead of using the word length, we don't use the word length. We will always use the word pitch. Why we use the word pitch? I already told to all of you. Friends, if you take the amino acid in the helix and if you arrange the amino acid in the linear form, this is the helix form and this is the linear form. So the length of the amino acid is not at all same. So that's why we don't use a word called as length. Instead of using the word length, we will use the word pitch. So what will be the pitch? 5.4 angstrom. So friends, one turn, the one turn pitch equal to 5.4 angstrom. Okay, then they can easily ask a question. What is the question they can ask? What is the distance? Please remember the question carefully. What is the distance between per rise residue? Don't get confused here. What is the distance between per rise residue? Friends, here the word rise representing amino acid. So one turn contain how many amino acids? 3.6 amino acids. We all people know that. And what will be the distance? What will be the pitch? 5.4. So friends, then the distance between one amino acid to the another amino acid is 1.5 angstrom. That's what we can call rise per residue. Okay, so don't get confused. Now I will ask one question. Everyone has to calculate it in a simple way. So my question is, one turn contain 4.5 amino acids. One turn contain 4.5 amino acid. Now pitch equal to 12.4 angstrom. Can you please tell me what is the rise per residue? Everyone please calculate and tell me, friends. One turn contain 4.5 amino acids, and pitch here it's representing what, friends? Length. The length is 12.4 angstrom. Now my question is, what is the rise per residue? You have to calculate what is the distance between one amino acid to the another amino acid. Let's take this as a 12.5. Pitch is 12.5 angstroms. Friends, listen to me. Pitch is 12.5 angstrom. How can you calculate, friends? Please tell me what will be the answer. Very good, Apurva. So what we have to do, 12.5 by 4.5. So how much we will get? In and around 2.77. So friends, the rise per distance between one amino acid to the another amino acid is the 2.7. So friends, like this also they can ask the part B questions, which you people has to remember compulsory. Okay. Now whatever I am going to explain you is the most important. I am requesting all of you pay utmost attention. Friends, currently what we have studied is the alpha helix, right? And we will discuss the beta pleated sheets in the upcoming slides. Friends, before studying the beta pleated sheets, every student has to remember one important point. What is the important point every student has to remember? You should not think that there are only alpha helix. There are many other type of helix also can exist in the secondary structure of a protein. I repeat the statement, not only the alpha helix, friends, there are many other type of helix also can exist in the secondary structure of a protein. What are the other type of helix? Every student please remember, friends, you have to remember all. Other type of helix, 2.7 ribbon, 310 helix, and whatever we have studied is the alpha helix, and friends, pi helix. So friends, there are different type of helices are present in case of a secondary structure of a protein. There is no rule that every secondary structure of the protein should contain only alpha helix. That is absolutely wrong statement. So the secondary structure of different type of proteins, friends, they can contain different type of the helix. Some contain 2.27 ribbons specifically, and some proteins they contain only the pi helix specifically. So friends, please look into the diagram, everyone, carefully. Pitch equal to P, number of repeating units per turn, equal to N. Rise per repeating unit, nothing but distance. So the simple formula to calculate is D equal to P by N. Correct na? We already studied that. P equal to 5.4 angstrom, that is the pitch. N equal to 3.6. So 5.4 by 3.6, so the successive distance will be the 1.5. So I want you people to remember this particular simple formula, D equal to P by N. Now friends, what I want you people has to remember an example. Here I want every student has to remember how many atoms. Please remember, friends, how many atoms involved in a helix. How many atoms involved in a helix? It is very important, friends, and it is mandatory, you have to remember. Okay, so please listen, try to understand. These are all the carbon. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5 and carbon 6. Okay, these are all the carbons. So now let's look into the one by one. So let's understand our alpha helix. In our alpha helix, you have to remember how many amino acids are involved in the alpha helix, how many atoms are involved in the alpha helix. This is what we have to understand. Similarly, in the 2.27 ribbon, you only look into the 2.27 ribbon. Look into this, amino acid 1, amino acid 2, and see friends, there will be a 7 atoms. Now all the students look into the diagram very carefully without confusion. 1, 2, 3, 4, 5, 6, 7. Now you all people has to get a valid doubt. Sir, why you are not counting this 7 and why you have counted this 7? Because from this 7 once again the new amino acid is starting. And anyway, this atom, this 7th atom is not involved in the ribbon formation. So what I can say? I can say that there will be a 2.2 amino acids are involved. There is a presence and 7 atoms. So that's why we can call 2.27. Now there is another helix friends. We will be calling it as the 310 helix. Why do I call it 310 helix? You only look into the diagram very carefully. In case of a 310 helix, how many amino acids are involved friends? You can see the picture very clearly. There is involvement of one amino acid, there is involvement of second amino acid, there is involvement of third amino acid, and this is starting with the fourth amino acid. So we no need to consider that. And it includes how many atoms? 10 atoms. You can see right very clearly. So starting from here, there will be a 10 atoms and 3 amino acids are involved. That's what we can call it as the 310 helix. Do not get confused with that particular point. So friends, the next one, if you look into the alpha helix till here how many amino acids? 3 amino acids. Now you only look into this, and friends, it is not complete fourth amino acid. So then what I can say, 3.6 amino acid or 3.5 amino acid with 13 atoms. So friends, the alpha helix will be 3.5 and 13 atoms. And friends, if you look into the pi helix, you can see here how many, this is the, please look into this. So 1, 2, 3, 4, 5, 6. So when you look into the alpha helix, how many atoms are involved? 16 atoms. So you can say 5.5 amino acids with 16 atoms. So what I can conclude, 5.5, 16 is the pi helix. 3.5 or 3.6 with 13 atoms is the alpha helix. 310 helix, 3 amino acids, 10 atoms. 2.27 ribbon, 2.2 amino acids with 7 atoms. So you should not think that there is only presence of one type of helix, that is alpha helix. There are many other type of helix also can be existed in the secondary structure of a protein. That is the statement I want you people to remember. Okay, so friends, what we have studied is helix, but we were clearly understand that friends, the secondary structure of a protein, what did I tell you? Friends, it consists of a alpha helix also, and friends, it consists of the beta pleated structures also. This is what I told to all of you, correct na? Now what I want you people to remember, we studied the alpha helix and beta pleated. What is the statement I have given to all of you? I have given a statement that friends, 90% of the proteins in their secondary structures, it contain alpha helix also, as well as my friends, even it contain beta pleated structures also. Please do not get confused with that. Now let's look into the beta pleated like structures. All the students look into this. This is the sheet. Friends, when you look into this diagram, what you can imagine, please imagine the solar plate. Friends, if you imagine the solar plate is exactly like this. Solar plate is like this, and it contains a lot of lines, correct na? This is a simplified structure of a solar plate. Similarly, if you look into the beta pleated sheet, it contains a sheet. On the sheet, what are present, friends? You can see, right? There will be a presence of the beta strands will be present. Don't get confused with that particular point. Now my friends, the question is very clear. What are the major forces or the major bonds that are involved in the beta pleated structures? Undoubtedly friends, I can give the answer is that hydrogen bonding only, like the alpha helix. Friends, there will be no involvement of R groups. Please remember that particular point. Friends, you can see, right, this is the sheet. This is the sheet. The sheet contain many strands. You can see. Now the question is, every student remember, one beta pleated sheet contain how many beta strands? 1, 2, 3, 4. See, I am using the word average. I am always using the word average. One beta pleated sheet contain 10 to 15 beta strands. 10 to 15 beta strands. One beta pleated sheet. Now, one strand contain an average. I am using the word average, friends. I am using the word average. It contain 10 to 15 amino acids. Now, what kind of a question they can ask? They can ask a question that calculate the total number of amino acids are present in the 100 beta pleated sheets. This is the question. What's the question they asked? Calculate the total number of amino acid present on the 100 beta pleated sheet. So if one beta pleated sheet contain 10 strands, average, we will always consider average, 10 strand, and one strand contain an average 10 amino acids. So 10 into 10, 100. So friends, one beta pleated sheet contain, I am using the word average, 100 amino acids. So since they have asked for the 100 beta sheets, so 100 into 100, 10,000 amino acids. Okay, what I have given you is an average. Okay, it depending on the given answer in the exam, you people has to choose the option carefully. But for the exam point of view, you people always remember the average values without fail. Average values without fail. Now friends, listen to me. We have discussed, right, the alpha helix can be exhibited in the parallel also as well as the anti-parallel also. Similarly, the beta pleated sheet also will be in the parallel direction, anti-parallel direction. So parallel direction means what, friends? They are moving only in the one direction. See here, N terminal to C terminal domain, En terminal to C terminal domain. But if you look into the anti-parallel, one strand is moving N terminal to C terminal domain, another one is moving in the opposite direction. So that's the reason what we can say that both are anti-parallel in nature. So the beta pleated sheets contain the strands that exhibit in the parallel also, that exhibit in the anti-parallel also. Friends, please look into the diagram very, very carefully. You can see, right, this is the sheet, this is the strand, this is the turn. You can see the picture very clearly. Now friends, the question you people have to remember, if you look into this diagram, the two strands are moving opposite direction. So what we can say that they are moving anti-parallel. Correct now friends? And if you look into the second diagram, what you can say, both are moving in the same direction. We can use the word that both are moving in the parallel direction. And if you look into the third direction, they are also moving on the same direction, which is the parallel direction. But friends, the point is very clear. Whether it is moving in the parallel direction, whether it is moving in the anti-parallel direction, doesn't matter. So they will always move, listen my statements, they will always move on the sheet with the help of a turn. You have to remember this, with the help of a turn. Now every student listen my statements carefully. It is not necessary, friends, listen to me, it is not necessary that the turn should be present only out of the sheet. That is wrong statement. The turn can move from above the sheet also, the turn can move below the sheet also, the turn can move out of the sheet also. The turn can move out of the sheet, the turn can move above the sheet, and friends, the turn can move below the sheet also. But however the direction they are moving, it doesn't matter, friends. The turns basically will be helpful to the strands to move either in the parallel direction or on the anti-parallel direction on the beta sheets. Don't get confused with this particular point. And friends, please look into the diagram carefully. Let's take a protein. If you take a protein, please remember, friends, protein contain alpha helix, protein contain beta plated. Everyone keep it in your mind. The alpha helix in a protein always arranged on the outer region, always arranged in the outer region, whereas beta pleated structure, they will be always located in the inner region. See, every student has to remember why the beta pleated sheets are not arranged on the outer region. You all the students look into this, you are all able to see a arrow like structures here. All these arrows are what? All these arrows only we can call it as the beta pleated structures. You can see here beta pleated structures always buried in the middle. What will be the reason? They will be all buried in the middle. The ultimate reason is, my friends, they contain hydrophobic amino acids. What kind of amino acid that they contain, friends? They contain strictly hydrophobic amino acid. That is the reason only, friends, we will be calling it as beta pleated sheets are immersed or associated only in the inner region. Whereas alpha helix also contain hydrophobic, there is no doubt about it. But alpha helix majorly contain hydrophilic. That's why alpha helix can be associated on the outer region. Do not get confused with that particular point. Friends, please look into the possible super secondary structures. I have clearly mentioned and I told to all of you that, friends, every protein having alpha, beta. There is no doubt about it. Some protein contain only alpha, some protein contain only beta. Now look into the combination of these super secondary structures. An example, a protein which contain beta turn and alpha, and a protein only contain beta. This protein do not contain any alpha. And look into the third protein. This particular third protein, I am telling the combinations, friends, they contain only alpha. So let me write the possible combinations. The first combination, the protein contain only alpha helix. The second combination, the protein contain only beta sheets. The third combination, it contain alpha, beta, alpha. The fourth combination, it contain beta, alpha, beta. And friends, if you look into the fifth combination, alpha, alpha, beta, beta. And if you look into the sixth combination, beta, beta, alpha, alpha. If you look into the seventh combination, I am talking about the repeating units. Alpha, 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 beta, beta, beta. If you look into the another combination, beta, 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 alpha, alpha, alpha. So friends, it is exclusively depending on what? It is exclusively depending on the length of that particular protein. What, friends? It is depending on the length of that particular protein. The second point is the nature of that particular protein. Depending on the length, depending on the nature of that particular protein, friends, different type of super secondary structures were proposed. So friends, we understand so far the primary structure as well as the secondary structure. In the secondary structure, friends, we have studied the alpha helix as well as the beta pleated structure. Now, please every student listen my statements very carefully. If you look into the tertiary structure, I have given you one important statement about the tertiary structure. What is that important statement? Because friends, here you don't get any kind of a difficult question. If you get a question, you will get only the statements. Trust my words, apart from the statement, there is no way of asking a question here. So that's why you have to remember compulsory question. The tertiary structure is the most biologically active structure. Tertiary structure is the most complex structure, and friends, the tertiary structure only we can call it as the three-dimensional structure of a protein. Now the point is very clear. When we are studying about the secondary structure, when I ask you, friends, what forces are involved in the secondary structure of a protein, everyone has given me the answer that hydrogen bonding is the major force that is involved in this particular secondary structure. Similarly, if you look into the tertiary structure, because here you can get the part B question also, what kind of amino acid, what kind of structures are most abundant in stabilizing the tertiary structure? Hydrogen bonds, van der Waals interactions, hydrophobic interactions, ionic interactions, disulfide linkages. I want you to compulsory remember. In a given part B question, they can ask that all of the following interactions are stabilizing the tertiary structure except, that's the point you have to remember. In other words, they can ask that which of the following interaction is not involved in stabilizing the tertiary structure. You have to remember every single interactions. Now friends, listen my statements. Whatever the protein that is present in the tertiary structure, every student remember, it contains several domains. Okay, don't all the students listen. This is one domain. This is one domain, and it is connected with an alpha helix or a beta pleated structure. Another domain, once again it is connected with an alpha helix or beta pleated. Another domain, once again it is connected with alpha helix or a beta pleated. It is having another domain. Now what is the special point every student has to remember? The point you have to remember that domains are individually also functional. What friends? Domains are individually functional. What do you mean by that? Which means that I have separated this domain. See, imagine this is the first domain, second domain, third domain and fourth domain. What I have done, friends, I have cut this particular first domain from this particular second and third, fourth. Now do you think the first domain will become inactive? Not at all. The first domain is also inactive, and even though the second, third, fourth, they get dissociated from the first domain, no problem at all. Second and the third and fourth also individually active. My friends, the statement every student has to remember is that the domains present in the protein, they will be active individually also, but when they combined together, they will perform majority of the functions. Remember, they'll perform majority of the functions, they'll combine with each other. Friends, let's take in a wonderful example. What we can take, friends, let's take an example of RTK. Let's take an example of RTK, receptor tyrosine kinases. When you look into the structure of a receptor tyrosine kinase, what you have to remember, it also contains different kinds of domain. You know, right? RTK contain extracellular domain, transmembrane domain, my friends, then followed by the cytosolic domain. Now all the students listen my words very carefully. Friends, you know what I have done? I have removed extracellular domain. I just cut it. When I cut the extracellular domain, do you think the transmembrane domain and the cytosolic domain, will it be active or inactive? 100% friends, the transmembrane domain and cytosolic domain will be active. Don't get confused with that particular point. Now every student listen to me very carefully. Now this particular extracellular domain got removed out. Do you think when it got removed out, will it perform the function or not? Will it be active or not? Of course yes, it is active. That is the reason I can say that one protein contain many domains. What friends? Many domains, and every domain is absolutely functional part. See friends, it was written very clearly that many proteins are organized into multiple domains. Domains are the compact globular units that are connected by a flexible segment of the polypeptide. It was written very clearly that each domain is going to contribute for this specific function. That's what we discussed, right? Extracellular domain, transmembrane domain, cytosolic domain, all are having the different domains. Let's take an example, RNA polymerase enzyme. Let's take an example, DNA polymerase enzyme. DNA polymerase enzyme having core subunit and it is having beta clamp. RNA polymerase enzyme also having core subunit and it is having a sigma factor. Now friends, you can say sigma factor is one domain, core enzyme is one domain. So core enzyme having a different function, sigma factor also having a different function. But what's the point? The core enzyme and the sigma factor come close together, they are going to make the RNA polymerase enzyme. Similarly, the core enzyme and the beta clamp come and close together, they can form the DNA polymerase enzyme. So what is the point? They can act individually also, they can act together also. Don't get confused with that particular point. So friends, you only look into this. This is a 3D structure of a protein, but which is not folded. Correct na? You can see that it is the linear structure. Which is what structure? Linear structure. That is the reason we will be calling this as the unfolded polypeptide. My friends, please look into the diagram. You can see, right, the unfolded polypeptide contain hydrophilic R groups also, hydrophobic R groups also. This is in the unfolded condition. Now what I have done, I kept this particular protein in the water, in the folded form. I have kept this particular protein in the water or an aqueous environment in the folded form. When I kept in the folded form, every student please look into the diagram friends. All the hydrophilic R groups will go out, and you can see, my friends, all the hydrophobic R groups will be immersed in the inside. You know what is the statement I would like to highlight? This particular hydrophobic R groups only will convert in or will develop into or will differentiate into beta pleated structures. So that's what you can remember easily. Wherever the beta pleated structures are present, there more number of the hydrophobic amino acids will be present when compared to the hydrophilic. And where the hydrophilic are present, friends, you can see the diagram, right? Hydrophilic are present on the this direction. Now what you have to remember? You have to remember that here basically they are made up of the alpha helix, which are in the outer region. Don't confuse and don't forget, friends. Okay. Now one second. Now what about the quaternary structure of a protein? Every student remember, till tertiary structure, we all people use one common point. What is the most common point we use? In the tertiary structure, primary structure, secondary structure, there is only one polypeptide. There is only one polypeptide, there is no doubt about it. But when we heard the name of a quaternary structure, the point every student has to remember that there is a presence of more than one polypeptide will be present. So it may be 2 also, it may be 10 also, it may be n number of polypeptides also. So each polypeptide, suppose example, there is a protein. An example, there is a protein which contain 5 polypeptide chains. Each polypeptide chain we will be calling it as the subunit. How many are there? 1, 2, 3, 4, 5. 5 chains are there. That's why we can call it as the oligomeric protein. If all these subunits are of a same type, then we can call that particular protein is the homopolymeric protein. If all the subunits are of a different combinations, then we can call, friends, heteropolymeric protein. Now friends, please listen. What kind of bonds that are stabilizing this particular quaternary structure? There is no doubt about it. Hydrogen bonds, van der Waal, hydrophobic, ionic, disulfide, and there is another linkage, friends, a salt bridge. These 6 will be involved in the stabilizing the quaternary structure. But instead of asking all this, if they ask you only one interaction that is making the quaternary structure into highly stable. Just now I told to you, right, this is one subunit, second subunit, third subunit, fourth subunit, fifth subunit. Keep it in your mind, most of the time they will all become stable by the disulfide linkages only. Hence the statement I would like to conclude, all these bonds are compulsory required. There is no doubt about it. But among all, if I ask you only, if I point out to describe only one force that stabilizes the interaction of tertiary is obviously disulfide. Always every one of you remember this particular point without fail. Okay. So friends, I'll upload the PPT in the app. So I'm requesting all of you without fail revise it. You have to revise the proteins compulsory, because friends, it is important for the part B also as well as the part C also. Okay. So friends, in the tomorrow morning 11 AM class, we will discuss the February 2022 question paper. Okay. In the 11 AM class, we will discuss February 2022 question paper. I will discuss 50 questions at a time. 50 questions. I will discuss 50 questions at a time. So what we will do is, tomorrow itself we will finish the part B. Whereas 3 PM we will start the enzyme kinetics. Okay, I'll finish it faster because we have revised it. We will finish it faster. We will majorly focus on the Michael-Mentel's equation. Okay, from where we are expecting the questions. Okay, and I told to all of you that the mock test will become live. I am requesting all of you today 9 PM. Please take the mock test. My sincere request. I am not over exaggerating. In this particular mock test which is happening on the 9 PM, there are 140 to 145 questions are there. So part A 20 questions, part B 50 questions, part C 75 questions. Okay, same like a CSIR paper. I am just giving the assurance, if you secure above 55%, I can tell you very surely that you can get a minimum 50% in the CSIR exam. So treat like an absolute mock test, absolute test of a CSIR. Please pay attention. Now my final request, please spend 3 hours on the mock test. Please spend 3 hours, because the ultimate goal of the mock test is that you can spend exact amount of time which you are going to spend in the examination hall. And my sincere request to all of you, don't attempt questions if you don't know. Don't attempt the questions if you don't know. Exactly write like a CSIR exam only. Okay, I will do my best to give the video solutions. If not, I will give the solutions, but if you have any doubt, I will solve every single question according to your doubts. Okay, so spend 3 hours, do every question slowly. Okay. Okay friends, tomorrow 11 AM we will meet. We will start the February 2022 paper discussion fast, and in the tomorrow afternoon we will do the enzyme kinetics. Okay, by 15th September, whatever I have given the morning time, the schedule, I'll finish it completely. Okay, so prepare well and write the test today 9 PM without fail. Okay, there are total 6 tests are there. I want you to write the 6 tests without fail. please write. Okay, I'll see you in the tomorrow morning class 11 a.m. sharp.